Hello everyone, this is Traveling Tradesman. I wanted to cover a circuit breakdown. This circuit is a very simple one, but still I know that they can be overwhelming if you've never seen one before, and maybe you just want to do a DIY at the house kind of thing. So what I'm going to do is break it down here for you. This is a project that I have going for my Massey Ferguson 135. You can apply this to anything outside of this. This is not limited to this one application. So let's break it down here. I'm going to look at this first loop that I have. Every time I do a diagram, I will break it down into sections so we can follow it step by step. Just a whole lot easier to teach it that way, and it overall makes more sense and doesn't bombard you. So here, for my application, this is going to concern just the Massey Ferguson tractor. So I have a source. We could either use the battery, but in my case, I'm going to actually use the the power coming from the ignition switch because I only want power on this circuit whenever the tractor is on. So that's where this source is actually coming from. You could run it to your battery if you want it to. Just depends on what your case might be. So here I have a SPST, single pole, single throw switch, better known as on-off control. The most basic switch, think of the one that's in your house. Just turn the light on, turn it off. But of course, this is automotive switches that I'm using. It's the same thing, just rated for weather. Here we have a relay coil. What's a relay coil? Well, you've probably heard of relays. Um, for my case, I'm actually working with a 4-pin relay. I got it at O'Reilly's. It's the most basic one you can get. This is a very basic application, so we got to keep it simple. So here, the relay coil. You'll notice whenever you look at your relay from the store, you'll see that there's numbers on top of it. Probably don't know what it is. Don't worry, just nomenclature. It means nothing because I'm going to break it down here for you. So the 85 and 86 on this relay, it actually specifies the coil. On a relay, you have the coil side, which acts as an inductor. So whenever you send power to this, think of it as maybe it, it energizes the coil and actuates the switch on the inside of the relay. So if you've ever put power to a relay, or maybe you're in your car and you hear a clicking noise, that's a relay clicking on the inside. So just power going through a coil actuates your switch down here. So that's the end of this loop. That's all this thing will do is turn the switch on, send power to the coil, completes that loop. Now let's bring our focus down to this second loop here where the magic happens. So here we also have another source coming in. So we have to energize this side as well. And I'm also going to bring power in from you can bring it in for the battery, or you can also bring it in on the ignition switch. I'm probably going to bring this in from the battery side because this is only going to be actuated whenever the tractor is on, because that's how I'm going to initiate this first loop. So we're going to treat this as this is going to be the battery of the tractor. And this 30 and 87, you'll also notice that it could also be different numbers as well. That's just for my case. That's what the numbers are on my relay. So that specifies that this is a normally open relay. So whenever this coil receives power, whenever I close this switch, it's going to actuate this internal contact on the relay, therefore transferring power from our battery across these contacts through this fuse we put a fuse in for safety because this is the load side, and we're going to run this straight into our light. And with the light, you can either ground it to the body or you can bring it back to the negative side of the battery. We just need to complete the loop. I'm probably going to terminate it somewhere shortly after on the frame because I don't want to have to run the wire all the way back to the battery. So why, some of you might be looking at why do we run a fuse on this side and not this side. So we're running a fuse on this side, excuse me here, we're running a fuse on this side here because this is the load side. Yes, there is a load here. This does generate a load, but this is going to be generating a heavier load because we have an output here that's going to be drawing current to the source. We're going to put a 25 amp fuse in here because that's what the light had called for. So that's how we spec out a circuit. This is very simple. I know it can be overwhelming, but just take it one piece at a time. Leave a comment below, and thank you for watching.